Welcome to Logarithms Part 2. And what we're going to do is try and analyze the graphs of logarithmic functions. Now, what I've done here is I started off with this function g, which is a good old exponential function, b to the x, and I drew more or less what these graphs look like if the base is greater than 1. So this is an exponential function. Now remember, what are logarithmic functions? They are the inverse functions of these related exponential functions. So in other words, if I switch the x's and the y's, okay, I would get this. And if I wrote that not in this exponential version, but the logarithmic version, this is what we are talking about. Okay, so this is log base b of x. So this is the function that we're talking about here, or you could even say this is g inverse of x, and that's what I'm trying to graph. So how am I going to get the graph? Well, the nice thing is, so this is the goal here, is to graph this guy down here, this inverse of this original g of x function. So how do we graph it? Well, we had a trick, remember? We simply took this original graph and we reflected it across the line y equals x. So here's the line y equals x. Okay, and I'm going to reflect my original graph across that line. And then I'm going to have a picture of what this logarithmic function looks like. You know, what does this look like? Well, let's start off with a bit of a foothold point. Instead of 0, 1, we're going to spin it around and make it 1, 0. So there it is. And then if we just do one sort of zone at a time, this part of it is going to go like this. Okay, and that's just this part here flipped across the line. And then this part here, if I flip it across, it's going to do something like this. And there it is. There is a logarithmic graph. There is g inverse of x. And now this was for a base that's bigger than 1. So that's going to be true of my inverse graph as well. So this is what a logarithmic graph looks like, again, provided in your logarithmic function the base is greater than 1. So base 2 or 3 or something like that. What are some key characteristics of this inverse graph? Like, what would the domain be? Well, the domain, or the x values, seem to be everything to the right of this y-axis. So it looks like x's are greater than 0. Range seems to be, it goes down forever and it goes up forever. So I'm thinking all numbers, or all real numbers. We have an x-intercept, okay, just the one point, and that's at 1, 0. And there's a vertical asymptote. That's the last sort of important characteristic, a vertical asymptote, and it's the y-axis, so it's the line x equals 0. Okay, so that's our first look at one logarithmic graph. Now I'm going to use exactly the same strategy. So I'm just going to clear off the screen. Only this time, what if my original function that I based this off of, which is still an exponential function, so I go, yep, let's cut to the chase and let's get to, we know what the inverse function is going to look like. Okay, we know it's, when we do all the rearranging, we get log base b of x. This is the inverse of that original exponential. However, let's just, for the sake of argument, this time, make the base a fraction. All right, so let's paste in a grid here, and let's see what that would look like. Well, we know that the original graph, g of x, exponential function when you have a fraction for a base, looks something like this. This part goes up like that, and this part kind of roars down like this. So now what I'm going to do is exactly the same thing. I'm going to take the line y equals x, and I'm going to reflect it across. Okay, so here was g of x, the original, Now let's graph the logarithmic function. Well, it's going to look like this. What you're going to get is you're going to get the point, instead of 0, 1, it's going to be 1, 0. So that point there. Then you're going to get this point that's on the line, it doesn't move. So it's going to guide me a little bit here. It's going to go up like that. And then if you take this guy here on the right and you flip it across, it's kind of up here going like this. Okay, that's just this part flipped across. Then this guy here flips across and goes like this. Okay, so this is my logarithmic graph. And you'll notice domain x's are greater than 0. X-intercept is still the point 1, 0. Our vertical asymptote is still x equals 0. So it's got all the same basic ingredients. Now, the only other thing to talk about, so that's basically what your two graphs look like. So if I just clear the screen, basically, if you're looking at a function like this, somebody says, please graph this. Okay, you have two types of graphs. On the one hand, if your base is greater than 1, you have a graph that essentially does this. Okay? And we know this is the point 1, 0. Now, if the base, on the other hand, is a fraction, okay, then our graph will look kind of like this. It comes down like this, and then roars off like that. And again, this is the point 1, 0. Okay, so that's the basic two types of logarithmic graphs that you have to know. Really important, though, is to understand that there are certain restrictions on both the x's and the base. So those are the two basic restrictions. If you're talking about domain or x restrictions, if you look at both graphs, it's very clear x's have to be greater than 0. And what that really means is, if you look back at your logarithmic function, if you take a log of a number, this only ever works if this number is a positive number. Okay, you cannot take the logarithm of 0 or the logarithm of a negative number. It's got to be positive. So anytime you take log of a number, it's got to be positive. And the other restriction is same thing for the base. The base has to be positive, and in addition, the base is not allowed to equal 1. Okay, so there's the base of your logarithmic function. As we know from our exponential functions, bases are greater than 1 or bases are positive fractions, but it's positive greater than 0 but never equals 1. These are important restrictions. There are no restrictions on the y, because y goes up forever and down forever in either graph, so y can be anything. All right, well, that's our basic look at logarithmic graphs, and I think that's where we're going to stop for now.